Yeah, just to confirm that the audio is on. Yeah, I think the microphone is also on. So yeah, I'm just going to go through kilonewtons. Yeah, so now we're gonna go to chapter 5. Last time we ended on I think it's continuity. We discussed some questions on continuity. We also covered trig limits. So today we're going to be beginning with ordinary functions, which are derivatives. So looking at the chapter, we're going to start by revising certain parts of grade 12 that some of you might have done them. I think everyone who was doing maths did this. So now they say, now I'm going to try to read it and hear what they say. They say one of the main problems of calculus is that of finding the slope of the tangent line at a point on the graph of function. So we're going to be looking at the tangent line, which will just be a revision. So this tangent line, we're going to be looking at it where we're going to be using first principle, dealing with the slope of a tangent. So all this information is just there, and it's not that compulsory, but let me check. Okay, yeah, I think it's better we start here. So here, yeah, I think it's from this page. Let me see, it's from this page. I want us to look at this definition. Definition 5.2. Now they say if y is equal to f of x defines a function of f at x, then the limit as h approaches 0 of f of x plus h minus f of x all over h, if it exists, it is called the derivative of x with respect to x. So this is what they're saying, that this is called f prime of x. You see that they say that this is called the derivative of f with respect to x. So, and they say that is denoted by, thank God they wrote here, it's denoted by f prime of x, which is read as f prime of x. So now they say the process of finding the derivative of a function is called differentiation, right? That we know. And they say other ways of denoting the derivative of y is equal to f of x are dy over dx. Also we have d of f of x or over dx. Then we have dxy, dx f, and these ones. So what we know initially is that y is equal to f of x, right? And we know that finding the derivative of f of x is written as f prime of x. It means that we can also put y prime. So we have this, right? And this are one thing. And again, we know that y is equal to f of x and dy. So if I want to derive this y with respect to x, right, I'm going to do this. Let me just use a different color here. I'm going to write d over dx. Now I want to derive y with respect to x of y, right? This will be equal to, even this side, I write d over dx of what? Of f of x. You see, this is this. You see, and this is this. So they're just trying to tell us that this is the same thing. And dy over dx can also be written as, now let me come here. If we have y equals to f of x, dy, your d over dx can also be written as dx. You see, right? And this would mean dx y is equal to dx f, right? Then this will be phi, or you write f of x, and this would be this would be this. You see, right? Then this will be the case. So that's how these are generated. So you can use any, you can find the question paper using any. You should just have to get familiar with them. But most of the times we're gonna be using either this one or this one or the one of y prime. These are the ones which you're gonna be using the most. So now we come to one-sided derivatives. We learned from one-sided limits, also from continuity, that really, let's talk about one-sided limits. We learned that when you're deriving something, or when you're approaching something from the right, you put plus there. You see, when you're approaching something from the left, you put minus. And we learned from continuity that if something is right continuous, it means that it has a plus there. If it's left continuous, you have a minus there. So the only thing that we changed is derivative. You see, still the same thing, left hand, right hand. So once we talk about right hand derivative, we now put plus. We are approaching 0. H is approaching 0 from the positive. H is approaching 0 from the negative. Now they say, the definition says a function y is equal to f of x is differentiable on a closed interval. You see, this is taken from continuity over a closed interval. So if something is differentiable, it means that it must be continuous. So we say that is differentiable on a closed interval a b if, number one, it has a derivative at every interior point. Now check this. This is almost taken from a closed interval. Continuity over a closed interval. Remember, what continuity over a closed interval says is this. So you remember, let me write here or write here. First, it says that continuity over a closed interval says that it should be continuous over the open interval. Then it talks about left hand continuity and right hand continuity. And if this is equal to f of a, we would say that it is left continuous, right? And if this was equal to f of b, we would say that it is right continuous, given that these two are defined. You see, so this is just taken from that part of continuity. So it should be simple for us to work around it. So first, we say that this is it has a derivative at every interior point or in between a and b over the open interval. So we say that also the right hand derivative at the endpoint exists. At the endpoint what? A. Then the left hand at the endpoint b exists. So I think we can go to the examples and then we apply what I'm talking about. So we come to this definition 5.4. They say that a function has two-sided derivative. We even talked about two-sided limits, right? At the point if and only if the functions right hand and left hand are defined and equal at that point. So if we check the left hand right derivative and the right hand derivative and we find that these two are equal, then we can now say that it is a two-sided derivative. You see, if they're equal, the left hand and right hand, so we mean that the derivative exists, right? So we look at these examples which these ones are coming from high school. Now let's say use first principle to find the slope of the parabola at any point on the curve, right? So in other words, we should take this and derive it using first principle. They say at any point on the curve. So we're not going to really specify which point, but they're saying at any point. Then the second one, they say find the slope of y is equals to x squared plus 1 at this point. So this is our x. After deriving, we're going to plug minus 3 on x. And then they say write the equation of the tangent at the tangent to the parabola at this point. We remember the equation was y is equals to mx plus c. So we're going to be using such cases. So let me do this. I think it's better if I just create a, it's fine, let me just create a page. So this is A, right? We're doing A. We're doing A. They're saying we should use first principle to find the slope of the parabola. So first we need to define, right? You see here they defined the equation first. They said the slope of the parabola is given by, you define the parabola first, the equation of first principle. You see, you need to define the equation of first principle first. So it means that we're going to say here the equation, we can take it as f prime of x. This is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Don't forget f of x is equal to what? Now let me do this. I'll shift this. I'll shift this. And I shift this. Yeah. And then the equation was x squared plus 1, right? X squared plus 1. So they're saying that we should use first principle to find the slope of the parabola at any point. All right, that means that using this equation we need f of x plus h, then we need f of x. You see, f of x already have it, so here I can write f of x plus h. In other words, wherever there's x, I'm gonna replace it with x plus h. You see, right? So I'm going to write this x plus h squared plus 1. So this would be the limit as h approaches 0 of x plus h squared plus 1. I'm just going to direct substitute, and our f of x is what? I'm going to put it inside the bracket since this thing has two terms. So plus 1. You see, all over what? H. And this would be the limit as h approaches 0 of x squared plus, I take h by, x by h by 2, then that's it. That is 2xh plus h squared minus x squared minus 1 all over h. And this would be the limit as h approaches 0. X squared will cancel x squared. So I'll do this. And I forgot that one there. I forgot the one somewhere here. Forgot plus 1. And the 1 will cancel the 1. You see, so in most cases we should be left with only those that have h. So I'll have with 2xh plus h squared all over h. Reason being, we need to get rid of the h below. So the idea is always to get rid of this h. So this will be equal to, the limit as h approaches 0 of, I factor out h, to x plus h all over h. Then the h will cancel out, right? The h will cancel out. Then we'll be left with the limit as h approaches 0 of 2x plus h. Then from here we can direct substitute. When we direct substitute, we don't write the limit anymore because we're direct substituting, right? We know that. So it means that from here we'll be left with 2x. So that will be the equation of a tangent slope. This will be the slope of the parabol. Now they say we should find the slope of y is equal to x squared plus 1 at the point. Already we found the slope, right? But we need to find it at what? At the point P. So now we're going to say this. We come to B. We're given that P is minus 3, 10, right? And we know that f prime of x is equal to 2x. And given f prime of minus 3 will be equal to 2 minus 3, and this will be equal to minus 6, right? If you check here, that is really, they say that at any point xy, the result in A shows that the slope of the parabola is this, right? And then at the point, now I want to check, this one is the slope of this at any point. You see, now I want to check it P minus 3 plus T minus 3, 10. Then we substitute that, we get minus 6. You see, right? And then now we go to C. See, we can use the two types of equations. See, they say they want the equation, write the equation of the tangent to the parabola at this point, right? And this is also our M. You see, right? If you can check here, our M in this case is minus 6 at that point. So want the tangent, the equation to that tangent at that point. So it will be minus 6. So let's just go back and apply that. So we're not going to use that equation. We're going to use this one off. So I'm going to use different equations so that you can compare it and check which one is simple. So here we have y is equal to, we have y is equal to mx plus c. You see, right? And then this would be y equals to mx plus c. And we know that m is equal to minus 6. Yeah, and also we have where p is this, right? Minus 3, 10. And this is our x value, this is our y value. You see, right? Then this would mean that this would imply that 10 will be equal to minus 6, x is minus 3, plus c. Now we're looking for c. Then this would be, this would imply that, so minus 6 times minus 3, I think it would be minus 18. Yeah, it would be 18, right? Then we'll have 10 minus 18, which is equal to c. And this would imply that c is equal to minus 8. Hence, y will be equals to minus 6x minus 8. So that should be the equation. If we check, that is the equation. Alright, so here they use a different equation. So, and myself, I use the different equation. So this is how it is. So I prefer the one which I used there. It's much simpler that way. This one, mx plus c, equation of a straight line. So now we come to number 2. They say we should find f prime of x if f of x is equal to this, right? Then we should find this. So I think here also they didn't use minus, they used the positive one. There was a mistake on this guide, because if they would have used the minus one, this thing here would be positive, because it's minus times negative, it will be like that. So I'm just gonna mask off this. So let me just write this. Yeah, so let me I think f of x is equals to 1 over 2x minus 3. F of x right, and we are told that we should find f of x is equals to the limit as h approaches 0 of f of x, not f of x, f of x plus h minus f of x all over h. You see, right? Then we are told to find this. So we know we have f of x, right? Now we need f of x plus h. So I can write f of x plus h, which will be, because wherever there's x, I'm going to replace by x plus h. We'll have 1 over 2 x plus h minus 3. You see, right? Then I'll direct substitute here. We'll have the limit as h approaches 0 of 1 over 2x plus h minus 3 minus our f of x will be 1 over 2x minus 3 all over h, right? This will be equals to, as h approaches 0. The best way to go about this is if we start by cross multiplying this. You see, right? And that will be 2x minus 3 minus 2x plus h minus 3. Then I multiply this. Then this will be all over 2x plus h minus 3 2x minus 3. But that's not what I want to do. You see, that's an old method. It's gonna take us time to do that. Now I wanna share a new method with you. Alright, I'm gonna share a new method now that you're going to use. So what you need to consider is, consider this denominator and this one. You're going to multiply them. You're going to have 2 times, or before we have 2 times, let's take out the 1 over 2. Let's take out the 1 over 2. going to have 1 over x plus h minus 3 minus 1 over x minus 3 all over h. Then I said we're going to consider these two, right? What you're going to do, we're going to multiply them. You're just going to have x plus h minus 3 times x minus 3. Then I also divide by that. This will come here. This comes here. You see? Then this will be 1 over 2, the limit as h approaches 0 of, if this one comes here, it's going to be like this. Let me show you. X plus h minus 3, x minus 3, all over x plus h minus 3. You see, minus x plus h minus 3, x minus 3, all over x minus 3. And this, not this, this will cancel this will cancel this, right? Then looking at the denominator, this one will come to h. Then we'll have h over x plus h minus 3. You see, right? Times what? X minus 3. And then what will happen is this. I shouldn't even have written this step. I just want to show you from, I won't write it from going forth. I'll just say it with my mouth. You just hear me saying it. Then here at this side, we're left with x minus 3 only. Then on the other side, we're left with x plus h minus 3. You see, all over h times x plus h minus 3 times x minus 3. And then this will be 1 over 2, the limit as h approaches 0 of x minus 3 minus x minus h plus 3 all over h x plus h minus 3 x minus 3. And this will be 1 over 2, the limit as h approaches 0. The 3 will cancel the 3 and the x will cancel the x. So I said that you should always be left with the ones that have h, unless if we're dealing with one-sided limits, then that's a different story. But if it's not one-sided limits, one-sided derivatives, then this should always be the case. Should always be left with the ones with h. If you're not left with the ones with h only, it means that you made a problem. And we're not supposed to summarize the denominator. We're not supposed to multiply through or anything. Don't do anything to the denominator. Just write it as it is until the end. Then the h will cancel. We'll be left with minus 1 over x plus h minus 3 x minus 3. And this will be 1 over 2. Now I plug. Alright. If I plug 0 there, I'll be left with x minus 3 x minus 3. See, right? And then this will be equals to 1 over 2 all over, no, it's fine, let me not be in a hurry. I'll just write like this. Then the x minus 3 can combine, they become squared. Then we'll have minus 1 over 2 x minus 3 squared. You see? Then that's the solution to that. So what is it? That's what they got. You see? So any question on this? Any question? Any question? Any question, guys? Okay, no questions. So I think this one was a problem. What's the problem? Can you try to check then the group, guys? Because myself, I can check the phone and check what I'm doing at the same time. You can check with him if he's not hearing what I'm saying or what. So yeah, so if there's no question, we can proceed, right? Then they say, show that f of x is equals to f of x is equals to the absolute value of x is not differentiable at x equals to 0, right? And they say we must check if it's not differentiable at x equals to 0. So it's not differentiable at x equals to 0. You see, right? And the first question is, what do you know about this? From chapter 00, right, page 8, we know that the absolute value of x will be x if x is greater or equal to 0, and it will be minus x if x is less than 0. You see, right? So that will be the case. So first, for us to solve this, we need to apply first principle. I'm going to say f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. And they say we must check if it is differentiable at what? 0. So this will be f prime of 0. We start by checking the condition. You see? And this will be the limit as h approaches 0 of f of all over h. I don't know who's knocking like that crazy on my door. Right? And then this will be equals to, now we check. Already, we know this. So, in other words, what we're saying is that wherever there's this, let me come here and say this. Wherever there's f of 0, we're gonna plug this, you see? And wherever there's f of 0 plus h, we're going to plug this, you see? So this can be done in two ways. You can either start like this, or I think what they did here, what they did here, it's either, I think they did the opposite. So it's either you can just start by doing this, you plug this, then you plug the 0 after, right? So you can do it in two ways. So I think, yeah, let's just do it the same way they did it. It's fine. So we can do it how they did it. Let's do this. Because I think your lecturers are new, so you might have a problem. You find out that they follow the slides. So we have x. We have x, then we can plug after, right? So means that when we follow now the syntax of the guide here, we're going to say now this is still the same thing. So let me just change this. We know what f of x is and what is f of x plus h. So f of x plus h, I've shown it here. It's the absolute value of x plus h. So what I did is, remember I said that wherever there's x, we'll replace by x plus h. So we'll have this minus the absolute value of x. So this is what done with this. We can now replace x by 0. You see, right? So we can just do that. Replace x by 0. And this will be the limit as h approaches 0 of absolute value of h over h. So in this case, since we know this, it will be simple for us to know what is the absolute value of h. You see, right? So let me write it down here. So we know the absolute value of h. So I can just come and plug the absolute value of h there. So we know the absolute value of h. So let me do this first. We know the absolute value of h. The absolute value of h will be positive or minus if h is greater or equal to 0 to be positive, and if h is less than 0 to be negative. So in other words, what I'm saying is that so this will be like this. The limit is, or maybe let me transform it one step by step, right? So if I come here and divide by h, this will be, if I divide this by h, this will be 1, this will be minus 1. Is that right? As h approaches 0 from the right, and then as h approaches 0 from the left. And then now I need to come and put the limit, right? The limit as h approaches 0 of this will be equal to, here this is approaching from where? From the left, you see? Of 1 will be 1. So I can just leave it as 1. It will remain 1. Then it will remain minus 1. From there, you see, I was just transforming it 1 by 1. So I think what they did here, let's see what I did and see if we differ from them. So you see what they did? They knew the absolute value of x is, of h is this. Is this, right? Then they said, but they divide by h there. You see, then we know if we divide h by h, we get 1. Negative h by h, we get minus 1. And this is the same as this step. Then they say, so that, then they wrote this separately. So I'll also do that. I'll write that separately as long as I'm explaining it. So what this means, the question is, what does this mean? This will mean that the limit as h approaches h from the positive of h over h will be equals to 1. You see, right? And then this will mean that the limit as h approaches 0 from the left of minus h over h will be equals to minus 1. So that's what they meant there. You see, they just interpreted that. So this will still mean the same thing. If we're approaching this from the left, we can choose, is it from the left? Yeah, we can choose minus h. If we're approaching from the right, we can choose positive h. So that will be the case. We can replace the absolute value by that. And then, so I think I can also put the absolute value because they did. So I'll put it like that. So now if you don't want to write it like this, right, how I did here, you can still write it like this. This would be the first option to choose. Then the second option would be, since we're here, right, you just say from there, we know that the absolute value of this over this would be, or you start by the absolute value of h. I always prefer that we start by the absolute value of h. H and minus h, when h is greater than or equal to 0, and when h is less than 0. You see, right? And then, now we come and write this, which is the same thing. We have 1. If we divide by h, then we'll have minus 1. H greater than or equal to 0, h less than 0. And if we consider this one, right, from the right, we would say that the limit as h approaches 0 from the right would be absolute value of h over h equals 1. Yeah, but I think it would still be the same thing. I think if we just write like this, it will still be the same. So let me not write this one. It will still be the same. So we just have to take it like this. It will still be the same thing. So this would be fine. Let's just use one method instead of using two. We can combine, we can stay with the one which is in the guide. So this will be it. And then now you know that, okay, let me not say this. You know that the limit as h approaches 0 of this does not exist. The reason why it doesn't exist is because since the limit as h approaches 0 from the left of absolute value of h over h is not equal to the limit as h approaches 0 from the right of absolute value of h over h. You see, right? Therefore, or hence, f of x is not differentiable at x equals to 0. You see, right? So this is not differentiable at x equals to 0. So let's come to the second question. What's the second question? Yeah, the same find if f prime of 2 it exists if this. Okay, so yeah, you see what I was saying, that term here, that term had started by plugging 0 0 on x, right? It started by plugging 0 here. Look at me cancelling. The term had started by plugging 0 0 0. You see, so I'll highlight these methods, right? Then you see when they say we must find f prime of 2 started by plugging 0, then you plug this after. You see, right? So you can do it in two ways. So we can choose to go like that, but I'd like us to stay with the format of the guide as much as we can, because if you get both ways take you to the same answer. You find out that you get total and then they try to penalize you. They're gonna try to find silly reasons, right, to penalize you. So let's look at number 4. They say we should find, let's see, it says we should find find f prime of 2 if f of x is equals to, what was f of x again? Oh, we must find if it exists, if f of x equals to 1 over root of x plus 2. Find if, yeah, sometimes they'll say find if it exists, or they just say find it. If we need to find it, we must be sure that it exists, right? If it exists, if f of x is equals 1 over the root of x plus 2. You see, right? Then first we need to know what is f prime of x. This is the limit. It's like every time you do this, you must state first principle. So this is us stating it. And then we take f prime of 2. Right? And here we should know this, that f of 2 will be 1 over root of 2 plus 2, and f of 2 plus h will be 1 over root of 2 plus h plus 2. You see, right? Then here we can have the limit as h approaches 0 of, we know f of 2 plus h is 1 over root of 4 plus h minus 1 over, no, but let's just plug it 1, it's fine. 2 plus h plus 2 minus 1 over 2 plus 2 all over h, and this would be equals to the limit as h approaches 0 of 1 over root of 4 plus h minus 1 over root of 4 all over h. And we know that I said that you should take this and this, you multiply them, right? It's root of 4 plus h times root of 4 all over root of 4 plus h times root of 4. Then this comes here, this comes here. You see, right? So this will be the limit as h approaches 0 of, if this and this will multiply and cancel, right? They'll be left with root of 4 minus, and this will cancel, or be left with root of 4 plus h all over h times root of 4 plus h times root of 4. You see, right? And then root of 4, we know it's 2. So from here we need to rationalize. We have root of 4 plus root of 4 plus h all over root of 4 plus root of 4 plus h. And then this will be the limit as h approaches 0 of 4, root of 4 times root of 4 will give us that, minus 4 plus h. As long as these are two elements inside, or terms, we need to put the brackets when we remove it. H 4 plus h plus 2 plus, it's not plus 2, this one is just 2. 2 plus, right? Then this would be the limit as h approaches 0 of 4 minus 4 minus h all over 4 2 root of 4 plus h 2 plus root of 4 plus h. You see, right? And that will be minus h. Is it 4 here or h? I wrote 4 by mistake. Here it's h. 2 root of 4 plus h 2 plus root of 4 plus h. Then the h would cancel. Minus 1 over 2 root of 4 plus h, 2 plus root of 4 plus h. Right, and this would be minus 1 over 2 root of 4 plus 0 and 2 plus root of 4 plus 0. You see, right? And this would be minus 1 over 2 root of 4, 2 plus root of 4. And this would be was minus 1 over 2 by 2, 2 plus 2. And that will be minus 1 over 60. Because it's 4 times 4. And if we check here, it's like that. You see, right? Then that will be the solution. Any question based on this? Any question, guys? All right. If there's no question, we can proceed. So we come to number 5. So I think, let me check. We're 5, 6. Yeah. So let's look at number 5. Then we'll next time when we come back, we'll come back to 6. Then now I'll give you exercises to write. And then tomorrow we'll be doing these exercises. So let me just say this. Let me just say try. Try this. And try this. And try this. Try this. And try this. And also I'll expect you to try and also here I'll give you 2. So let's do one that is more like these ones. Then you'll try this, right? If you can try this, you'll be ready for this topic. Yeah. And then, but though we'll do them in tomorrow's session. So I just want you to try them before the session, so that you can mark yourself when you're doing them. So we come to number 5, right? They say show that the function f of x is equal to this, has no derivative at x equals to 0, right? You remember the first one that had no derivative? It was this one. I said that even when you started this, you can start it like this, or you just begin here, or maybe you start by writing 0 here, 0. After writing this formula is very important. We can't alter it. We write this formula, then we come here, we replace x by 0 only. So you can do even like this, it's fine. So let's do it like that, because if you can see here, they're showing you 2 different methods. So I think it's advantageous for us to do that. So every time, what I'm going to tell you is this, right? So let me just write the question, then I'll explain this when I'm writing here. So every time we're dealing with one-sided limits, here they're saying that we should show, it's number 5, right? Say we should show that, what is the question saying? The function f of x equals x squared. This one is 2x what? 2x, x greater than 0, x less than or 0. Has no derivative, right? So it will show that it has no derivative. And x equals to 0. Right. So every time we're dealing with one-sided limits, right, we need to say this. Come on. We need to say this. Every time we're dealing with one-sided limits, we need to first say f prime of x is equals to the limit. We'll put the formula first. You see, right? X approaches 0 of f of x minus 1 over h. Then we want to show that it is no derivative at x equals to 0, right? So first we need to put 0 here on x, because these are one-sided, right? So we need to put 0. Then we come and do this. Now I want to check. We don't know which equation to choose because there are two. So the only way we can know how to choose an equation is if we know which side we're approaching from. You see, the first one we're gonna say f prime of 0 from the left, right? That there, you see, will be equals to the limit as h approaches 0 from the left of f of 0 plus h minus f of 0 all over h. So if this is approaching from the left, what will happen? That is the question that I asked myself. So we're gonna take the left is this one, right? X squared. So wherever there's x, we'll replace by 0 plus h. So this would mean that we'll have 0 plus h squared minus f of 0. This one, we always take the one where x is equal to 0. That one we don't choose side. We always take the one where x is equal to 0. And then in that case it's x squared still, right? So this would be 0. You see, right? Which is all over h. And this would be the limit as h approaches 0 from the left. And then we have h squared over h. And this will be the limit as h approaches 0 from the left of h, and that will be 0. And then now we can approach it from the right. You see? Now we can approach it from the right. We have f prime of 0 from the positive. And this would be equal to the limit as h approaches 0 from the positive of f of 0 plus h minus f of 0 all over h. And this would be the limit as h approaches 0 from the positive. So the one that is approaching from the positive is 2x. So we're gonna put 2, 0 plus h. And this one will always take the one which is equal to 0, right? And the one that is equal to 0 is x squared. So here we'll put 0 squared all over h. this will be the limit as h approaches 0 from the positive of 2h over h, and this would be the limit as h approaches 0 from the positive of 2, and that will be 2. And then here they said we should show that f of x, and this has no derivative at x equals to 0. So we're going to say, therefore, f prime of 0 does not exist. So that's what we need to prove. Does not exist since f prime of 0 from the left is not equal to f prime of 0 from the positive. You see? Then we deduce and say hence f of x, we're now answering the question, has no derivative at x equals to 0. You see? Then we're done. If we check, that's the case. If you're approaching from the left, you get 0. If you're approaching from the right, you get 2. Right? Then we say these are not equal, which follows that this does not exist. Hence, the function f has no derivative at x equals to 0. So that becomes simple like that. So I think you can try to look at this number 6, then you try these ones. Alright? Then after trying them, you can, we can do a corrections tomorrow. Can do a correction. There's no need to send them. Don't send them, just do them, then we will do a correction.